Okay, welcome to this video. We're going to use an exercise which I've adapted from the Oxford IB textbook to look at how we use space-time diagrams and investigate the relativity of simultaneity. Okay, it's hard to say that word. So what we've got here is a space-time diagrams where we're looking at two frames of reference. We've got a beacon and a spaceship. And you can tell that the spaceship's moving because that temporal axis is oriented at an angle theta. And we can measure that angle theta and discover the speed of the spaceship relative to the beacon. Now, what we also have are four events, W, X, Y, and Z, and these are flashes of lamps. Okay, so what they're going to do is emit light, and that light is going to travel to each the beacon and the spaceship, and we're interested in how we use the space-time diagram to investigate the motion of that light. Now, there's a couple of tasks on the screen. Okay, the first one is to determine the order in which the lamps flash according to an observer in S. Now, that's quite simple. The way that we do this in S is our stationary frame of reference. All we do is we draw lines which are parallel to the x-axis, and we kind of just wait and see how they interact with that CT axis. So, for example, we can see event W and Z, okay, they lie on a line which is parallel to the x-axis. And so these two actually flash at the same time, the same value of t. X then comes later, and Y is the last one. So in terms of the order of the flashes, W and Z go first, X then comes, and then Y is later. Okay. We could do the same from the point of view of the world light of the spaceship, but we have to be a bit more detailed here. The first thing I like to do is to try and draw my x-primed axis. Now that x-primed axis should be oriented to the x-axis by the same angle as the two temporal axes. I may not have done this entirely correctly because I'm doing this on a screen. And again, we just draw lines parallel to that x-axis. So you can see here that my event Z is the first one to go in terms of our second frame of reference, the spaceship. If we then go, we see that W and X are now simultaneous as measured by the spaceship, and then Y comes later as well. So again, this is a good demonstration of the relativity of simultaneity in that two events which were simultaneous in our first frame of reference are no longer simultaneous in the second, and also two events which were not simultaneous in the first frame are now simultaneous in the spaceship. Okay, so what I find is students are generally okay with this part so far. We're not using a lot of physics, we're more just thinking about the construction of the space-time diagram and how we use it to demonstrate simultaneity. The bit that's hard is that question 3. We want to demonstrate the order at which a light arrives at the spaceship. And for my students, I've said you've got to watch the light cone explainer. Well, that's what this is. So let's go for it. When we are considering the flow of light from points, so in this case, from these flashing lamps, we have to draw something called a light cone. Now, a light cone is quite a sophisticated shape in 2D diagrams. However, it's very simple. It is just two lines which are oriented at 90 degrees to each other, so they're perpendicular, and there's an angle of 45 degrees between that dashed vertical line as well. We know that light follows a world line which is oriented at 45 degrees, and that's why if we draw both the lines, 45 plus 45 equals 90. So when we're doing this, we remember that the speed of light is the same in all reference frames. And so that means we don't need to worry about which reference frame we're using. We just simply draw lines which are at 90 degrees to each other and respectively 45 degrees to the vertical. So I've drawn a light cone for event Z here. And why is this important? Well, what I can do now, I can measure the time which, firstly, my light from lamp Z crosses the world line of the spaceship. And that simply is just where it crosses at. And that will tell me the temporal coordinate as measured by the moving reference frame at which this light will reach the spaceship. I could also do the same from the point of view of the Earth, I simply have to just find the point at which we cross the CT axis, not the CT primed axis. So this allows me to say at what point in time the light arrives from each of the lamps in each of the frames of reference. So what I suggest you do, if you're trying this exercise or you have a copy of it, pause the video now and try and draw light cones for each of the other flashes, so W, X, and Y. If you can, draw your lines as close to 45 degrees from that vertical as possible, and they should be at 90 degrees to each other, and then see at what point they cross the world line of the spaceship, and in other words, the CT primed axis, and also our CT axis. So I'm going to assume that you've had a chance to try that. Okay, so I'm just going to put these on now. You can see there we've got our light cones for the 4 different lamps here, and it's pretty messy. Okay, I agree with you. It's quite a lot of lines and quite a lot going on here. However, it's very instructive to see what happens. Now, you'll notice here, if you look at the case of the spaceship, the next light cone to cross my CT primed axis is actually the light from Y. Okay, so we're going to see Z first at a low time, and then we're going to see Y next. And then actually, we're going to get the light from X. If you follow this line all the way up, eventually it's going to cross the CT primed axis. And then we're going to finally get the light from W at a later point in time, according to that spaceship. So you'll notice there, it's an interesting result that even though those 2 events, as measured by S primed, occurred at the same time, W and X, the light takes longer to travel from W than it does from X. Why? Well, they were a greater distance away. Light, although it has the fastest speed, is not instantaneous, and therefore it will take some time to arrive. So the light coming from X arrives before the light coming from W. We could do similar for the CT axis. Okay, you can see there that actually the light from Z and X arrives pretty much at the same time as each other. And actually, the light from Y and W appears to arrive at the same time here, although perhaps with a slight difference there. We just had W arriving just before Y. Okay. And that may be a slight error on my part in terms of the use of PowerPoint to make this slide. But if you've drawn it carefully, you should be able to mark out the order in which each of these events is observed by the observer that you're considering. Now, I appreciate that's a lot. Take your time. Feel free to watch the video again, ask questions, because this is a complicated topic. Equally, you might have it all clear now, in which case I'm sure there's plenty more past paper questions for you to try to practice this. All the best.